MS Ramaiah University of Applied Sciences.
Hi students, let us discuss Boy's gas calorimeter. The aim of this experiment is to determine the calorific value of a given gaseous fuel. Here the principle used is the first law of thermodynamics or conservation of energy. A known amount of the fuel is burnt in excess of oxygen and the heat liberated is transferred to a known quantity of water. Then, by the first law of thermodynamics, heat lost by the fuel equal to heat gained by the water. M by T of fuel into CV equal to M by T of water into Cp into delta T, where M is the mass in kgs, T is time in seconds, Cp is specific heat of water in joules per kg Kelvin, delta T is temperature rise of water in Kelvin, Cv is calorific value in joules per kg. Apparatus consists of geyser, shell and tube type, heat exchanger with igniter switch and control valve for gas and water flow to burn the given fuel. Weighing scale to measure the gas consumed, thermocouple K-type with digital indicators to measure the temperatures, rotameter to measure the water flow rate. Figure shows the experimental setup. Follow the sequence of instructions step by step as given in the procedure. 1. Check all electrical, water connections and gas connections. 2. Allow water to flow in required quantity through geyser. 3. Allow the required quantity of gas using control valves. 4. Ignite the fuel using igniter switch and ensure stable flame through flame window. 5. After steady state is reached, note down the temperatures of water at inlet and outlet. 6. Note down the rotameter readings and mass of gas consumed for given interval of time. 7. Repeat steps 2 to 6 for different flow rates of water and gas. Observe and note down the following: rotameter, least count and range; weighing scale, least count and range; temperature reading, least count and range; type of gas or fuel, K equal to C plus 273.15, Cp equal to 4.187 kilojoules per kg Kelvin, Rho equal to 1000 kg per meter cube. Use the following table to register the readings for different trials. Calculate to estimate the calorific value as follows. Mass flow rate of water MW equal to rho V in kgs per second. Mass of fuel consumed MF equal to M1 minus M2 by T in kgs per second. Temperature rise of water delta T equal to T2 minus T1 in Kelvin. Calorific value Cv equal to Mw into Cp into delta T by Mf in joules per kg. Tabulate the values in the following table for all the trials conducted. Finally, estimate the average value of calorific value. The outcome of learning in this experiment empowers the student to analyze the effect of variation of gas flow rate on calorific value, analyze the effect of variation of water flow rate on calorific value, compare the average calorific value determined from the experiment with the standard value, identify the sources of errors and provide means or methods to alleviate them.
Hi students, today we will learn how to measure the calorific value of a given gaseous fuel. For this we require a setup called Boy's gas calorimeter. The Boy's gas calorimeter consists of shell and tube type heat exchanger which has two controls, So one control is for gas flow, another is for water flow. It also has a water flow rate measurement instrument called as rotameter, which reads in cc's per second. This is provided with a control valve so that the mass flow rate can be controlled for the given trial. So we also have a selector switch which takes inputs from the two thermocouples to read the temperatures of water inlet and water exit. So with this selector switch we have to choose which temperature we are going to use, and that temperature is displayed on a digital display. Now to measure the amount of fuel consumed, we are using a weighing scale which reads up to precision of second decimal. We have a source of gaseous fuel, that is LPG cylinder, which is domestically available. So this gas is being gas is being used to measure the calorific value. Okay. Now once we know the parts of the Boy's gas calorimeter, now let us see how the circuit of this gas as well as the water flow exists here. Let us look at the gas flow path. So from this source, that is LPG cylinder, the gas is flowing through these tubings and then enters the shell and heat tube exchanger at the bottom, and then after combustion it exits through this outlet. So this is the gas path. Let us see the water path. So water arrives here from the pipeline to the control valve. So you can set the control valve for a given water flow rate. Then it passes through the rotameter, and from rotameter it arrives at the inlet of this heat exchanger. Then after circulating through the coils, it goes out after getting heated through this pipe, which is sent to the sink. So at the inlet and the outlet there are two thermocouples to read the temperatures. After knowing the details of the gas calorimeter, let us now start conducting the experiment. So first you switch on the mains power supply. After switching on the power supply, ensure the water flow path by setting it to the maximum on the geyser control, and then operate this butterfly valve to read 75 cc per second flow rate of water. After setting the flow path of water through the system, next let us see how to set the path for the gas. For that we have to open this control valve for the gas from the source tank. So open it to 75% of the opening, and then you set the control to near to minimum on this geyser. Now switch on the ignition